Welcome back. Since we now understand the theory behind projectiles and how they're supposed to move and how they look, we're now going to focus on solving the equations that help us analyze mathematically and physically projectile motion and semi-parabolic motion. So today we're going to solve two exercises, one of each kind, step by step, to see how these exercises are solved. So what we need to remember first is that everything we do has to be separated into horizontal and vertical. And we're always going to work with those two completely separate, even using different equations and different variables. So remember, for horizontal, we're only going to have one equation, which is x equals vx times t. And for vertical, we're going to use the other three equations of motion, or kinematic equations, which are the following. Vy equals Voy minus g times t. Vy squared equals Voy squared minus 2gy. And y equals Voy times t minus 1/2 gt squared. And here we must remember that g is 9.8 positive. 9.8 meters per second squared. The other thing we need to remember is that the time in both equations is the same one. We're also going to use that the time going up for a projectile is the same as the time going down. Initial velocities in diagonal have to be decomposed into the horizontal and vertical components using sine and cosine. The vertical velocity at the top of trajectory is 0, and the acceleration is always only vertical, and it's always negative 9.8 meters per second squared downwards. So we're going to use all of these facts in these problems so that maybe they become more commonplace for you. So I'm going to write the first example on the board. So this is our example. A movie stunt driver on a motorcycle speeds horizontally off a cliff that is 50 meters high. How fast must he leave the cliff to land 90 meters away? So the most important thing is being able to transfer this into a diagram or a drawing that allows us to visualize what is being said. So it basically talks about a cliff. So we can draw the cliff like this. And on top of the cliff, there is a motorcycle. And it says that the motorcycle is speeding horizontally, so completely to the right. And the cliff is 50 meters high. So this height is 50 meters. And the question is, how fast must he leave the cliff? So we're looking for this speed or velocity in x to land 90 meters away. So that's horizontally 90 meters away. Something like this. So the trajectory of the motorcycle is going to be semi-parabolic motion. So that means it's going to look like a curve going downwards like this. Half of a parabola. And we need to figure out Vx. So the first step to solve a problem like this is to list all of the variables in horizontal and vertical and start looking for which equations we can use. So first we say horizontal and vertical. And we always have the same variables that can appear. For horizontal, we have the horizontal displacement x, the horizontal speed vx, which is only 1 because it's constant, remember there's no acceleration, and the time t. For vertical, we have the vertical displacement y, and we do have two different velocities. There's the Voy, the initial velocity, and the Vy, the final velocity. We have time and we have acceleration. So there are two here because it's not constant, but there's only one here because it is constant. So we just call it Vx. So now what we need to do is find these numbers in the question so that we can fill this in and see which equation to use. So let's see. First it says a movie stunt driver speeds horizontally. So horizontally means that initially it had no speed or no velocity in vertical. So this initial speed in vertical is going to be 0. So even though they don't give us a 0, we have to infer it from the problem. So horizontally off a cliff that is 50 meters high, 50 meters is the vertical displacement. So we can put that here in y. Then it says, how fast must he leave the cliff? So we're looking for the Vx, the vertical velocity, to land 90 meters away. And 90 was the horizontal displacement. So we can put that here in horizontal displacement. So because we're looking for something in horizontal, we're going to need to use a horizontal equation. So the only horizontal equation that we have is x equals vxt. So this is the one that we need first. So x, we already have it, it's 90. And vx, we're looking for it, so we can leave it as vx. But we need to multiply it by t, and we don't have t. So there's nothing else we can do with horizontal. There's no other equations, and we have no way of finding t if we don't have vx. So that's when we move to vertical to try to figure out t. So now what we're looking for is this t. Fortunately, we have another value that we always have, which is the acceleration. The acceleration is the acceleration due to gravity. So a is actually negative 9.8 meters per second squared, as it always is. So Vy doesn't matter, we don't have it, but we don't need it. So we need to find an equation that has y, Voy, t, and a, so that we're able to solve for t, but doesn't have Vy. So the first one doesn't work because we do have Vy, and there's no way for us to get it. The second one doesn't work either because, again, it has Vy. So the only equation we can use is the third equation. So let's write that down. Y equals Voy times t minus 1/2 gt squared. So this is the acceleration, 9.8. So what we do here is plug in all the values. So y, we know it's 50. Voy, we know it's 0, times t, which we're going to figure out, minus 1/2 times 9.8 times t squared. So immediately, because this is 0 times t, we can cancel that term out and ignore it. And something else is that this displacement is actually negative because it displaces downwards 50 meters. So the distance is 50, but because we start at 0 and we end at negative 50, our displacement is negative 50. So that's why we can put a negative 50 here, and the negatives cancel out. So we're left with 50 equals 1/2 times 9.8 times t squared. This is a number. 1/2 times 9.8 will give us 4.9. So we can put 4.9 t squared equals 50. And then to solve for t squared, we have to pass the 4.9 to divide down here. So we're going to end up with 50 over 4.9 equals t squared. Now, this will give us a number. Once we have that number in the calculator, in order to solve for t, we have to take the square root on both sides. So taking the square root on the right, we'll just cancel out the squared. So we'll end up with t equals square root of 50 over 4.9, which is actually 3.19 seconds. So this we can get using our calculator by plugging this in. 3.19, you can check it yourselves if you want. So once we have t, we can put it here, 3.19 seconds, and plug it into our horizontal equation, 3.19. So we need to solve for Vx by passing this to divide. So our Vx is equal to 90 over 3.19, which is 28.2 meters per second. And that's our final answer. So notice that we actually had to use both a horizontal and a vertical equation in order to solve for the result, even though the result was just horizontal. So now let's do an example for projectile motion and solve it step by step. Okay, so our second example of projectile motion says, a kicked football leaves the ground at an angle of 37 degrees and a velocity of 20 meters per second. Calculate the maximum height, the total time traveled, and the range of the projectile. So this example tells us a couple of things. First, it leaves the ground, so it'll start at 0. That means if we draw our ground and our football, it's going to start down here. Now, at an angle of 37 degrees, that means that the initial velocity is not horizontal or vertical. It's at an angle of 37 degrees, right? And a velocity of 20 meters per second. So this arrow has a magnitude of 20 meters per second. And because it's projectile motion and because of gravity, it's going to go up to a maximum point and then come back down and fall back to Earth. So what we're being asked for is to calculate the maximum height, which means this vertical displacement here, the y max, the total time traveled, so the time that it takes t at this point down here, and the range, which is the horizontal displacement, x. One thing that you need to keep in mind is that once we find the maximum height, if we find the time at that point, we'll get half of the total time, because the time that it takes to get up to the maximum height is the same as the time that it takes to get from the maximum height to the bottom. So if we find t here, we're going to have to multiply by 2. So let's start step by step. So again, the first thing we do is list our variables as horizontal and vertical. So again, in horizontal we can have x, vx, and t. In vertical we can have y, voy, vy, t, and the acceleration. So we can start by saying that, as always, the acceleration is negative 9.8 meters per second squared. Our times are going to be the same. Now our initial velocities won't be 0, not for y and not for x, because this speed of 20 will have components in x and y. So in order to figure out vx and voy, we need to use components. So if we remember from our triangle, if this angle down here is 37 and the hypotenuse is 20, the vertical will be 20 sine 37 and the horizontal will be 20 cosine 37. So you can use your calculator to calculate that, and you'll get that the horizontal is 15.97 meters per second and the vertical is 12.04 meters per second. So we can write that into our list of variables. The vertical, 12.04, and the horizontal, 15.97. So even though the problem says the velocity is 20, we won't use 20 anymore. We will only use 15.97 and 12.04 in each of the respective equations. So let's see. Let's start with the first one. What we're looking for first is the maximum height. So this y, but y max. So as I said before, in the maximum height, the vertical velocity, it's getting smaller and smaller, and when it gets to the top, it becomes 0. So this y that we're looking for means that at that point, the velocity is 0, because up here, the velocity in y is 0. So we need an equation that has y, voy, vy, and a, but not t. So we can't use the first equation because it has t. We can't use the last equation because it has t. So we need to use the equation in the middle. So let's write that down. And we start plugging in the variables. So vy is 0, voy is 12.04, and we have to put the squared, minus 2 times 9.8 times y, which is our variable that we're solving for. So this will be 0. We can leave this as 12.04 squared for when we put it in the calculator. Minus 2 times 9.8 is 19.6 y. So in order to solve for y, we can pass this one to subtract. So we get negative 12.04 squared equals negative 19.6 y. So y will be equal to this, negative 0.1204 squared, over, and we have to pass this to divide, negative 19.6. So that gives a height of 7.39 meters. That would be our first answer, our maximum height. This is our answer for maximum height. Okay, 1/3 done. Now the second one asks for the total time traveled. So we can do these two ways. We can either find the time at this point and then multiply it by 2, or we can find the time at this point by saying that the y will be 0 at that moment. What I'm going to do is use the values that we already have and then multiply it by 2. So we can put this here. Instead of the question mark, we have 7.39 meters, and our time is what we're looking for. So we can choose any of the equations. I'm going to choose the top one because it looks like the easiest one and the shortest one. So we can do that. Let's do it right here. So we have Vy equals Voy minus G times T. Our Vy is 0 at the top. Our Voy is 12.04 minus 9.8 times T. So we pass this to subtract. We get minus 12.04 equals minus 9.8 T. And then we pass the 9.8 to divide. So we get minus 12.04 over negative 9.8, and that will give us a time of 1.23. So that is the time at the middle, at the top of the trajectory. So the time that we're actually looking for, the total time, which we can call t tot, is going to be this times 2. 1.23 times 2, which is equal to 2.46 seconds. So again, this is our second result, 2.46, and it's the time at the end. And the last thing we need to find is the range. So for the range, we're going to have to use horizontal, of course. Now remember, time is the same in vertical and horizontal. So let's put 2.46 here in the time. And we need to figure out the range, which is the horizontal displacement. So for that, we can use our horizontal equation, x equals vx times t. And we're solving for x, so we don't have to move anything anywhere. Just plug in our values, 15.97 times the time, which is 2.46. So using that, we get a range of 39.2 meters. And that's it. That's our third result. That's the range. So what we figured out in this problem is that this height is 7.39 meters. This length is 39.2 meters, and the time it takes to go up and come back down is 2.46 seconds.